So again, sorry there, I was muted, and so one of the most misunderstood electrical rules is the 80% rule. Tonight we're breaking down how breaker sizing actually works and why electricians sometimes get it wrong. So one of the most misunderstood electrical rules is the 80% rule. Tonight we're breaking down how breaker sizing actually works and why electricians sometimes get quick. Quick summary. Breakers are designed to protect conductors. Breakers are designed to protect conductors for overheating. If a breaker is oversized, the wire can overheat before the breaker trips. Understanding breaker sizing and continuous load calculations is critical for safe electrical installation. If you're an electrician or apprentice, this is something you need to understand to avoid overheating and also fail inspection. So again, thank you guys all for tuning in to tonight's live stream. Again, as you guys enter, don't forget to like up the live stream. So we're I'm going to leave a quick summary right here, and I'm going to pull up. So again, breakers. Okay, I'm going to turn off one of these cameras here. Okay, so again, breakers are designed to protect your conductors. Um, many people are under the conception that breakers actually protect the equipment, and breakers do not protect the equipment. So again, for all those who are tuning in, and if you don't know what a breaker looks like, this is simply a breaker. Okay, this is basically a 20 amp two pole breaker, and basically what happens is you have to use the proper size wire gauge for this, and this will land number 12 wire will land on this breaker. Again, this is a 20 amp breaker, 20 amp two pole, and this is a GE type breaker. Okay, so very important. It's a double pole, 20 amp. It's going to give two hops out of here. So this is the correct process for the breaker sizing. And again, that's a number 20 amp breaker. And this is a 15 amp breaker that I have here. Okay, this is basically used for 14 gauge wire. So again, breakers will always protect the wire, and it will never protect the device. So for all those who are wiring, if you're wiring for your hood fan, microwave, and so on, make sure that you do have the proper gauge wire. Make sure you also have the proper size breaker to avoid the interruption that it can cause. So again, breakers protect the devices. And what I'm going to do right now is I'm going to pull up the rule for that. I'm going to share my screen for all those who are tuned in to the live stream. Simply don't forget to like up the live as you guys come in. It helps with the channel and the process. So I'm going to have we're going to go into rule 14-104, and this is going to basically give you the rule that's in here, and this is the rule that I normally correspond to. Okay, so we're going to hop on to that rule right now. I'm going to make sure that I can share my screen. So again, everything is taking time here tonight, and I'm trying to pull up the actual screen here. So again, for all those who are tuning in, simply don't forget as you guys enter to like up the live stream. And again, for all those who are here, if you want to leave a comment, drop a comment in the comment section. You can tell me where you guys are tuned in from tonight. And let's see if this rule has pulled up here. So for some reason, it's taking me a while here to pull up. So, okay, I'm going to continue until that rule comes up. So again, rule 14-104. So it basically says it's for your overcurrent devices. And again, breakers must not exceed your conductor ampacity. And what that basically means is, just like I said before, if you have your breaker, you have to have the correct size wire also for the circuit to work accordingly. So again, breakers must not exceed your conductor ampacity. Okay, so you're going to see on the bottom of the page here, you're going to see, just follow along with me here. It basically says 14-104, and it says overcurrent devices, and it's also leading you to Appendix B. And what that rule basically says is the rating or setting of overcurrent devices shall not exceed the ampacity of the conductors that they protect. So again, the rule is basically right there. And for all those who has missed it, it's 14-104. So the rule states the rating or setting of overcurrent devices shall not exceed the ampacity of the conductor that they protect, except where a fuse or circuit breaker having a rating or setting of the same value as the ampacity of the conductor is not available, and the maximum calculated or known load is in accordance with the rules of section B. No, sorry, section 8. And it also says the rating or settings given in table 13 shall be permitted to be used within the maximum value of 800 amps. So again, that's basically saying if you go to table 13, you are going to be allowed to use up to a maximum of 800 amps. And it's also telling you to go to rules of section 8 and table 13. And it says use within the maximum value of 800 amps. In the case of equipment wire, flexible cord in sizes numbers 16, 18, and 20 gauge, copper and tensile cord which are considered protected by 15 amps or 20 amps overcurrent, or if you go to the next page, it's going to say C as provided for by other rules of this code. So this is basically where you're going to get your rules from for your overcurrent protection. Rules 14-104. And again, for all those who are tuned in, 14-104 is overcurrent devices. So again, type yes if you've seen this mistake before. Let me know in the chat, residential or commercial. So it also goes on to say, 2, except as provided for by subrule 1, C, the rating of overcurrent protection shall not exceed 15 amp for number 14 gauge copper conductor, 20 amp for number 12 gauge copper conductor, 30 amp for a number 10 copper conductor, 15 amps for number 12 aluminum conductor, and 25 amps for number 10 aluminum conductor. So basically, again, for those who are tuned in, this is basically what they're referring to. These are the breakers. And again, you're going to see B, it says a 20 amp. So this is basically what a 20 amp breaker is. If you can see, let me slide it over a little bit. So this is basically a 20 amp breaker. Okay. And it says there in that rule, B, 20 amp for number 12 copper conductor. So you're going to have to get a number 12 gauge wire in order to power up this breaker. And it goes on to say a 15 amp breaker for a number 14 copper conductor. So 15 amp breaker is A, and this is basically what a 15 amp breaker looks like. As you can see, it has the marking here and so on, and it's basically saying your 15 amps. It's also going to give you the name of the breaker and so on, and it's going to tell you, SA is basically certified to be installed. So again, when it comes to all electrical products, they have to be certified in order to use them. And if you see that sticker here, that's basically the sticker that allows you to use this breaker. So that's basically what this rule is telling us in simple terms. So I'm not going to go on to read the other stuff here. Again, for all those who are tuned in to the live stream, thank you guys for tuning in. Don't forget to leave a like on the video as you come in. So again, so again, your breaker, for all those who are tuning in, this is Rule 14-104, and it basically is telling us that it's overcurrent device, and breaker must not exceed conductor ampacity. For all those who are tuning in tonight, prevents conductor overheating, and so again, a 14 gauge wire on a 20 amp breaker is incorrect. It's something that is not allowed. It's basically it's gonna allow you to fail your inspection once the inspector comes in to verify. So, like I said, the rule is up here on the screen, and for all those who has missed it, I'm going to read it over again before I move on to the next chapter. So 14-104, rating of overcurrent devices. It tells you to see Appendix B. I'm not going to go to Appendix B. However, Appendix B is a very important part of this rule. And basically, when you see a Appendix B, Appendix C, whatever it may be, is basically telling you to go over to that rule and verify. So the rating or setting of current devices shall not exceed the ampacity of the conductors that they protect, except where a fuse or circuit breaker having a rating or setting of the same value as the ampacity of the conductor is not available, and the maximum calculated or known load is in accordance with the rules of Section 8. The rating or setting given in Tables 13 shall be permitted to be used within the maximum value of 800 amps. In the case of equipment wire, flexible cord in sizes number 16, 18, and 20 gauge copper and tensor cord, which are considered protected by 15 amps or 20 amp overcurrent devices, or also tells you, as provided for by other rules of this code, except as provided for by Subrule 1C. The rating of current overcurrent protection shall not exceed A, 15 amps for number 14 copper conductor, 20 amp for number 12 gauge copper conductor, 30 amps for number 10 copper conductor, 15 amps for number 12 aluminum conductor. So as you can see, the difference between the A and D is one is copper, the other one is aluminum. And for the 15 amp for number 14, that's copper conductor. But then you also have 15 amps for number 12 aluminum conductor, and 25 amps for number 10 aluminum conductor. So that's the difference between your breaker sizing when it comes to aluminum and copper. So for all those who are tuned in to the live stream, as you guys come in, don't forget to like up the live stream, and we're going to go into section 8 right now. I'm going to put it up on the screen here so you guys can see. This is going to be the 80% rule that I'm going to go over to right now. So again, thank you guys all for tuning in to the live stream. So again, we're going to head over to 8104. That's the section I want to head over to. Okay, so here we are. So again, as you can see, this is section 8 of the code, and this section is very important. And again, this is the 80% rule for all those who are tuning in. If you don't know, again, section 8, it says circuit loading and demand factor. That's basically what it is. This section applies to A, maximum circuit loading, B, calculated loads for consumer service, feeders, and branch circuits, C, use of demand factors, D, branch circuit positioning required for dwelling units and heater receptacles for vehicles. It also says in 8-002, special terminology tells you to see Appendix B. And it says in this section, the following definition shall apply. Basic loads, the load of lighting and receptacle circuits based on the outside dimension of a specific area of building occupancy as listed in tables 14. Calculated load, the load calculated in accordance with the applicable requirements of this section. Demonstrated load, historically maximum demand watt information recorded over at least a 24-month period for the same type of facility as the one in question, equated to watts per meter square. And then it also tells you electric vehicle, energy management system, a means used to control electric vehicles, supply equipment, loads through the process of connecting, disconnecting, increasing or reducing electric power to the loads, and consisting of any of the following: a monitor, communication equipment, a controller, a timer, and other applicable devices. So we're going to go over, sorry, I lost it there for a second there. So the rule that I actually want is 8104, which is at the bottom of the live stream. And it's basically maximum circuit loading. And it tells you to see Appendix B. The ampere rating of a consumer service, feeder or branch circuit shall be the ampere rating of the overcurrent devices protecting the circuit or the ampacity of the conductor, whichever is less. The calculated load in a circuit shall not exceed the ampere rating of the circuit. And then it goes on to also say this is 3. So for all those who are tuned in to the live stream, don't forget to give the live stream a like up. The calculated load in a consumer service feeder or branch circuit shall be considered a continuous load unless it can be shown that in normal operation it will not persist for a total of more than 1 hour in any 2-hour period, if the load does not exceed 225 amps, or B, a total of more than 3 hours in any 6-hour period if the load exceeds 225 amps. A load of a cyclic or intermittent nature shall be classified as continuous unless it meets the requirements of Subrule 3. And then it goes on to say 5, where a fuse switch or circuit breaker is marked for continuous operation at 200% of the ampere rating of its overcurrent device. The continuous load as determined from the calculated load shall not exceed the continuous operation marking on the fuse switch or circuit breaker. And so we're going to go to 5A. Excuse me. Except as required by item B, shall not exceed 100% of the ampacity of conductors selected in accordance with section 4, or shall not exceed 85% of the ampacity of single conductors selected in accordance with section 4. When a fuse switch or circuit breaker is marked for continuous operation at 80% of the ampere rating of its overcurrent devices, the continuous load as determined from the calculated load shall not exceed the continuous operation marking on the fuse switch or circuit breaker, and, except as required by item B, shall not exceed 80% of the ampacity of conductors selected in accordance with section 4, or shall not exceed 70% of the ampacity of single conductors selected in accordance with section 4. The continuous load as determined from the calculated load connected to a cable bus shall not exceed the value specified in sub-rules 5 or 6. So again, as you see with the code, it gives you rules and it tells you to relay it back to the sub-rule. This is basically how the code book works. So I'm going to go on to read 8-106 also. And it says, use of demand factors. See Appendix B. In any case other than a service calculated in accordance with rules 8-200 and 8-202, when the design of an installation is based on the requirements in excess of those given in the section, the service and feeder capacities shall be increased accordingly. Where 2 or more loads are installed so that only one can be used at any one time, the one providing the greatest demand shall be used in determining the calculated demand. Where interlocks are installed to prevent simultaneous operation of electric, space heating, and air conditioner loads, whichever is the greater load shall be used in calculating the demand. Where a feeder supply loads of a cyclic or similar nature, such that the maximum connected load will not be supplied at the same time, the ampacity of the feeder conductor shall be permitted to be based on the maximum load that may be connected at any one time. Where a feeder or service supplies motor or air conditioner loads, a demand factor as determined by a qualified person So, okay, I'm going to read over 4 for those who are tuned in. Where a feeder supply loads of a cyclic or similar nature such that the maximum connected load will not be supplied at the same time, the ampacity of the feeder conductors shall be permitted to be based on the maximum load that may be connected at any one time. 5. Where a feeder or service supplies motor on air conditioner loads, a demand factor as determined by a qualified person shall be permitted to be applied to their loads, provided that a deviation has been allowed in accordance with rules 2-030. The ampacity of conductors or feeders or branch circuit shall be in accordance with the section dealing with the respective equipment being supplied. Notwithstanding the requirements of section, the amplicity of the conductors of a feeder or branch circuit need not exceed the amplicity of the conductors of the service or of the feeder from which they are supplied. Where additional loads are to be added to an existing service or feeder, the augmented load shall be permitted to be calculated by adding the sum of the additional loads with demand factors as permitted by this code to the maximum demand load of the existing installation as measured over the most recent 12 months period. So again, I'm going to go on to the so again, where additional loads are to be added to an existing service or feeder, the augmented load shall be permitted to be calculated by adding the sum of the additional load with demand factors as permitted by this code to the maximum demand load of the existing installation as measured over the most recent 12 months period. But the new calculated load shall be subject to Rule 8-104, 5, and 6. For loads other than those calculated in accordance with Rules 8-200 and 8-202, feeder and service load calculation shall be permitted to be based on demonstrated loads, provided that such calculated are performed by a qualified person as determined by regularly authority having by the regularity authority having jurisdiction. Where electric vehicle supply equipment loads are controlled by an electric vehicle energy management system. The demand load for the electric vehicle supply equipment shall be equal to the maximum load allowed by the electric vehicle energy management system. And it also said this is 11. For purpose of rules 8-201A, 8-2021, 8-2023, and it just continues to list out some rules there. So again, example on the if you have an electric heater, you cannot load. So let's say your electric heater is drawing 16 amps. Up yourself, Goon Platoon. Again, thank you for stopping into the live stream, and also thank you for supporting the channel. So a 20, if you have an electric heater, let's say it's drawing 16 amps. So a 20 amp breaker can safely carry about 16 amps continuously. So again, if you have a 16 amp electric heater, if your electric heater is drawing 16 amps, you can load it with a 20 amp breaker. This will protect the wire. Again, you want to be concerned with the overcurrent protection. So remember, you're always protecting the wire. So again, Type yes if you've seen this mistake before. Let me know in the chat, residential or commercial. So again, on the job, I actually use a breaker finder for this. Save time instead of flipping breakers. I've dropped the link. It's pinned at the top of the comments. It's pinned at the top of the screen. And it's again from Kiwi. So it's a Kiwi breaker finder. So I've dropped the link. Again, up yourself, Frynet. Again, thank you for stopping into the live stream. You have to pay attention to the finer details to spot the mistakes, right? Yes, definitely. You have to pay attention. Again, it's important when it comes to electrical. So all details are very. You have to pay attention. So that's why I have this rule here. And basically, what this page is, this is the code book. It's part of the code book, and this is where I normally find the rules. And again, it's very important because there's a lot of details in these rules that you can miss, as Gloom Platoon said. You have to pay attention. There's a lot of details in here that a lot of people are not aware of. Even licensed guys also will make mistakes. The reason being is because we're so quick to read the code book that we miss the importance of what we need to know, and a lot of times we'll miss that. But if you do read it over twice, you can't miss it. Oh, okay. Yes, Frynet. Again, thank you for the support. Definitely trying to put the work out here. That's why you see I've gone a different way of a full in-depth masterclass series. It helps get the content out there. So again, thank you again for stopping in and supporting the live stream. And again, it's very important to pay attention to fine details. So for all those who missed the opening of the live stream, you can catch it on the replay. I would have covered some sections tonight. Basically, Rule 8-104. This is the rule right here. And I would have covered also 14-104. It's basically overcurrent device. And this is where you find majority of your rules. So again, this is the 8-104 is a 80% rule. This is where normally you do your 80% rule calculation. For many of you who have followed my channel, you've probably heard me talk about the 80% rule. So this is basically where the 80% rule comes out of, 8-104. And basically what it is if you have a breaker like this, for instance, this is a 20 amp 2-pole. Now, this breaker, you have a 12 gauge wire on this breaker. And basically, you cannot oversize the conductor. You cannot overload the current, sorry. But what I mean by that is you have to have up to 80%, and you have to have a 20% left over. So what this 20% basically does, it helps protect the wire. In sense, if there's any overheating going on, it's going to trip the breaker. So a lot of times you'll see a lot of people having issues with their circuit, with their breakers, and you probably will see that that breaker didn't trip. It's because of the 80% rule that it didn't kick in. So when you have too much on the load on the circuit, when you overload the circuit, you that 20% cannot protect the wire that it's supposed to do. And when it's protecting the wire, it will trip the breaker. That's what it's supposed to do. Okay, let me go to the comment. Most professionals go off of experience because the work is like muscle memory, often not following the code, but that's why a lot of jobs look sloppy when you look behind the walls. Definitely, Glue and Platoon. It is a mistake that a lot of electricians make. Again, me myself, I probably did in the future, in the past when I was younger, coming up. But because I know um, the safety behind all of what goes on right now, as a young apprentice coming up and a newly journeyman, you don't really know the difference. So you assume that the rule is always going to stay the same, but the rule don't always stay the same. The rules switch as soon as there's an issue in a home. Let's say there's a fire, there was a badly mistake oversizing the breaker, or let's say, for instance, you have the arc fault breakers that are installed. Um, those are installed for protection, um, and those are installed throughout the house now. So every time something happens, they change the rule, and a lot of guys are not aware of that because they don't um, either get either check on the rules, because you can check on the rules. You can pull it up and check on it to see if there's a rule change. So yes, a lot of times guys will just, it's called uh, guessing. There's a rule for it. Rule of thumb. They go by the rule of thumb basically. They go by what they were taught instead of double checking. I guess is being lazy, and that's why, yes, that's why you do have a lot of fires in the homes, and a lot of sloppy work. You'll find a lot of tape wire taped up behind the drywall instead of putting it into a junction box. So that is what basically goes on inside of the homes when you don't follow the code. Again, it's not everyone that's going to know how to find these rules. If you are a DIY, you're probably not going to find these rules as fast as I will. Um, I'm not sure. I don't really know. I'm just saying. But this is where we get our rules from. So, again, for all those who are tuned in to tonight's live stream, don't forget to give it a like. So, again, real installation examples. For instance, EV charger. Many times I install EV chargers, and a lot of times what happens is either the client have, you can either have one of those EV chargers that are rated for 60 amps. You can either have them rated for 40 amps, or you can either have them, I believe they go down to 20 amps. They're basically adapt adapters. You can change out the adapters. You can change out the settings in the Tesla vehicle. So let's say you don't have a lot of amperage in your panel and you have an EV charger and you want to use 60 amps, but you don't have the required space in the panel, because again, the panel does matter. If the panel is overloaded, you cannot install a 60 amp breaker for that EV charger. So what you can do is you can drop it down to uh, 32 amps, okay? But you're going to feed it with 40 amp breaker. You're going to feed it with a number 8 gauge wire, or if you're generous, you can use a number 6 wire. That's normally what I do, just in case the customer wants to switch back from um, the 32 amps to the 60 amps, but the 60 amps actually becomes 48 amps instead of 60 amps. So you still have that protection. You still need that protection, even though it's EV charger. You still need the protection to protect the wire. So if you are going to be loading at 60 amps, you're going to have to fuse it at 48 amps, which there is no. So what's going to happen is you're going to have the 60 amp breaker, but the actual EV charger is going to be drawing about 48 amps. That's the protection that's going to be kicking in. The wire and the breaker again leads back. You have to protect the wire on the circuit with your breaker. So again, you're not protecting the appliance, you're protecting the wire. Again, if you have a 32 amp, if you want to go to 32 amps for your EV charger, you use a 40 amp breaker with an H3 wire, and the 32 amps is you're going to have that 8%, that 20% that you need in order for your circuit to work accordingly. And again, these are all inspections, so you have to make sure that it is properly done. And again, with lighting loads also, the difference with lighting loads is it goes for 1500 watts. So lighting, we add, let's say you have a pot light and it's drawing 0.2 amps or 0.4 amps, whatever it may be, add those up. And as long as you're not over 1500 watts, so you have to be about 1200 watts for your circuit to work accordingly. So that's the lighting load. So again, number 14 is normally used for a lighting circuit, but you can step it up to a 12-2 wire. All depends on the distance also. That's probably going to be another live stream. But the distance, when I say the distance, is there's a voltage drop. So it all depends on your distance and how big the house is. You will probably use a 14 or a 12. So that's why a lot of times you'll see the homes in the bathrooms with the light and the fans start to flicker because there's too much on the load. And the actual, I have to change this setting here, guys. 1 second here. Yes, definitely, Farnet. So again, when I'm going to change the, give me a second here for all those who are tuned in right now. I just have to, so this is real job site examples that I'm explaining right now for all those who are tuned in to the live stream. So a lot of times when you see your flickering going on in your washroom with your fan, you turn on your fan or you plug in a hair dryer for instance, and your light starts to flicker and it starts to do funny stuff. You turn on, you plug in your hair dryer, your lights are flickering. That means your plug and your light is connected together, and you're going to get that issue. What that issue is simply overload. Is called. You've overloaded the circuit. You've basically mixed up um, motors with lighting. Um, there's nothing wrong with mixing. There's nothing wrong with putting your bathroom fan and your lighting on the same circuit. The problem is if you have too much load. Let's say you have your plug, your bathroom GFI, and you plug in your hair dryer, and it's connected to that. Then you have too much load. It's going to start to flicker and so on, and it's probably going to overheat. So that's basically the lighting circuit. So again, it's very important to make sure that. So again, even on jobs, I've seen 14 gauge wire on a 20 amp breaker. It's not correct. And again, if you are going to have an inspection, it doesn't matter if you're going to have an inspection, you should always try to do the job correctly, regardless. Some jobs don't require inspection. Most jobs require inspection. It depends on what you're doing. So if you don't have an inspection and you don't require an inspection, you should always try not to put a 20 amp breaker on a 14 gauge wire. The voltage is different in a commercial building and a residential building because of the size or because of the expected amount of a plant. So yes, so in residential, there's not a lot of it's not a lot of big loads going on. So the voltage is definitely going to be different. Um, in residential, you normally have a 100 amp panel, 200 amp panel, or you go up to a 400 amp panel. You have also in between 150 amps, but again, they don't have a whole lot of load. Even your EV charger don't draw a whole lot. So when it comes to homes, it depends on the size and what you're going on. If you do check out my videos, you'll see the current home I'm working on. It's a pretty large home, and it's a 400 amp service because there's a lot of stuff going on there. When it comes to commercial now, you have to calculate it according to the specs. So in commercial, what happens is they normally give you a set of specs. Everything's laid out, everything's planned. You have basically your basement drawing, you have your tenant drawing, stores if there's going to be in there. So they're going to calculate that load accordingly. And again, in commercial, it's three-phase system. So what happens with the three-phase system is you're allowed to share neutrals. So when you start to share neutrals and so on, it becomes a lot different from residential. You're basically sharing neutrals in order to have your circuit flow efficiently. So that's the difference between residential and commercial. Residential is single phase. I hope I'm explaining it properly to you. But yes, the voltage is definitely a big difference in commercial. Like I said, commercial is I can I'll actually go to the commercial rule now that you brought it up, and you will see. Okay, So right here, this is rule 8-204. So I'm pulling this up because someone in the chat mentioned something. For all those who are tuned in, don't forget to like up the live stream also. So schools, for instance, schools, this is a commercial building. Um, it says the calculated load for the service or feeder shall be based on the following: a basic load of 50 watts meter square of classroom areas plus 10 watts slash meter square of the remaining area of the building based on the outside dimension plus electric space heating, air conditioner, and total loads of other permanent connected equipment based on the rating of the equipment installed, plus, except as permitted by Rule 8-105, 10, or Rule 8-10611, any electric vehicle supplied equipment loads with a demand factor of 100% plus cord connected equipment intended for connection to receptacle rated more than 125 volts or 20 amp base on 80% of the rating of the receptacle or the rating of the equipment intended for connection to the receptacle. Demand factors shall be permitted to be applied as follows. For buildings with an area up to and including 900 meters squared based on the outside dimensions, as permitted in section 62, for any electric space heating loads provided for, and 75% for the balance of the load. So this is basically where we get our calculation loads from. So there's a big difference between residential and commercial. Again, commercial, you do have a lot of heavy equipments going on. So the load factor is going to be a lot bigger. And again, commercial, it's 600 volts, while residential is 300 volts. So there's a big difference. And that's why you'll see a lot of times when they're doing um, in commercial um, tenant restaurants and so on, or strip plazas, you'll see that they'll bring their power in to the disconnect and they'll leave it. It's up to us as the electrical contractor to go in and calculate the load that we're going to be allowed inside of that commercial industry. So the yes, it is a big difference. So again, on jobs, I've seen number 14 wire, 20 amp breaker. And again, that's a problem when it comes to overheating. You can't have anything or overheating. So I'm going to go on to common. Okay, so again, I'm going to show this here. So again, for all those who are tuned in to the live stream, again, if you haven't seen the breaker I use to test, is simply a breaker finder. It's pinned at the top of the chat. So that's basically the breaker finder that I use to test my circuit. Great tool. It finds it. Yes. No problem. Gloom Platform. You're welcome. So again, I'm going to. That's the breaker finder that I use to basically find my circuits. Okay, so we're going to go into a quick recap, and then I'm going to go on to live questions. Anyone have any questions? There will be a live Q&A after I finish the recap here. I will do a live Q&A for those who wants to chat or so on. I will do a live Q&A. So basically, this is a quick recap, and what I did go over for the live stream tonight, for all those who are tuning in to tonight's live stream, I'm just going to give a rundown of what I went over. And again, what breakers actually protect. So breakers protect conductors. They don't protect the equipment, and a lot of times people are under the conception that the breakers actually protect the equipment, but the breaker is not there to protect the equipment. It's there to protect the wire. That's why you have to have, if you have a 14 gauge wire, you have to have a 15 amp breaker on that circuit. If you have a 12 gauge wire, you have to have a 20 amp breaker on the wire. If you have a 10-tree wire, you have to have a 30 amp double pole breaker on it. And if you have an 8-tree wire, you have to have a 40 amp double pole breaker on that in order to protect your wire accordingly. Again, you can oversize your wire, but your wire has to be able to fit inside of the breaker itself. So let's say, for instance, this is a 20 amp breaker, and if you have a number 10 gauge wire and you want to install it on this breaker, you have to make sure that it's going to fit in the slot here. So I don't. Okay, so very, very important. When you are sizing your breakers, if you are going to oversize your wire, just make sure that your wire will fit in the breaker. So again, breakers protect the wire. They don't protect the device. Also, I would have went through Rule 14-104. Yes, Gloom Platoon. Thank you again for the stopping into the live stream. Also, thank you guys again for the support. So again, Rule 14-104 is basically where you're going to find your overcurrent device. So that's basically where you're going to find your breaker rules and so on. And it simply goes on to say breakers must not exceed conductor ampacity. It prevents conductor overheating. And again, 14 wire on a 20 amp breaker, that is a big mistake. And it's also, you're also asking for a field inspection. The inspector will fill the job. 14 gauge wire on a 20 amp breaker, you're not going to pass that job. You will get a defect. You will get a defect. It's a simple swap out for breakers. And Rule 8-104, this is the rule that I'm currently in. And again, maximum circuit loading. Continuous load must be calculated at 125%. Example math. 20 amp breaker, 12 times 20, 80%. It's a 16 amp 16 amps, you're going to have continuous load. Electric heater drawing 16 amps. A 20 amp breaker can safely carry about 16 amps continuously. So again, type yes if you've seen this mistake before. Let me know in the chat if you've done residential or commercial. So again, I'm going to live Q&A for all those who are tuned in. If you guys want to drop a comment, you can. Again, when it comes to the actual trade and working the trade, it's not a guessing game. Basically, everything is calculated. You know, there's a nameplate on every single item that you buy, whether it be your if it's dealing with electrical. Let's say, for instance, you have your toilets. A lot of the new toilets have the receptacles that are required. They have the lights inside of them and so on. When you walk into the washroom, the cover will lift up. So those require a nameplate. They also require a it's called a CSA sticker. Okay, and a CSA sticker, what it does is it allows you to basically install that device. Without a CSA sticker, you're basically asking for issue. So this is the breaker I have here, and if you look at the front of the breaker, you're going to see around here there's a CSA stamp here. That's basically what you're looking for when you're installing your devices. You have to make sure that it is on you have to make sure you have that CSA standard on it. Bloom Platoon says, even on small jobs, wiring or rewiring, you have to check for any breaks in the wires before you say complete. Even the wires sometimes are not perfect when you unroll. Yes, Bloom Platoon. So most new wires will come perfect, but the problem is when you're pulling the wire. So it all depends on how you pull the cable. There is something called it's a wire stool that you use, and basically what you do is you will set up your wire on the wire stool, and once you start to pull your cable, you always have to pay attention to what you're doing. Yes, I have run into that issue where once you start to pull the cable, you can damage the wire. And when you do walk away from that job, and if the drywall is up and so on, you're going to have an issue. That's why a lot of times when I do my roughing, I make sure that before I have my inspection, let's say I go for my first inspection, my roughing inspection, I make sure I do a walkthrough before I actually call for the inspection to make sure there's no broken wires and so on. And also, again, the way you staple inside of the homes, or even on again, commercial is different. A lot of commercial jobs you use EMT, tech cable, so on. Residential is mostly the NMD 90 and so on. Those wires that you're going to see on the screen here, the set of yellow cable here you see on the screen here, that is what we normally use in residential. And what happens is those cables, when you start to pull them, if you do catch on your nail, it's going to get damaged. So yes, it's a lot different. Um, but again, if you have, like I said, wire tracer, you can trace your wires out also. There's a lot of stuff you can do to make sure that your actual wire is actually safe at the end of the run. You can basically test your wire through continuity, whether it be by using a meter or by actually using your toner. There's also a toner you can use to wring your wires out. So there's many different things you can use to try to protect yourself when it comes to that. So again, when it comes to me sizing my breakers and so on, whether it be commercial or residential, you have to make sure that you calculate the load. You have to make sure that you calculate what you're putting on that circuit. Most times, if I am doing a job and the client has, let's say, they have a oven built in, those hardwire ovens, I want to make sure that I have the appropriate um, amperage. So I will check the nameplate and so on. Even your air conditioner outside, it has a nameplate on it. Basically, that's how you find your amperage. Again, there's also, you either go up or, or go down. It depends on the circumstance of what you're doing. So it's very important to, you know, to basically size your cable accordingly. Make sure that your breaker is sized accordingly. So I'm going to, that's basically the quick recap here. I'm going to just going to live questions here. And again, for all those who are tuned in to the live stream, don't forget to like up the live stream. Helps with the channel. So again, for all those who are tuned in, welcome back to the channel. I'm Fabian from Fabian Electrical Services Inc. And again, this is my YouTube channel that I'm running. And for all those who are, if you missed this, you can catch it on the replay. And if you do have any questions, you can drop it in the comment section. Again, what breaker sizing mistake do electricians see most often? You can leave a comment if you've ever seen breaker sizing mistakes on the job site. Normally, you're going to see the 15 amp and the 14 gauge. You will normally see a 14 gauge wire on a 20 amp breaker. And the reason why that happens is because the circuit is overload. If a circuit starts to overload, many people, many homeowners, and many other people will think that it's because of the actual breaker. So what they'll do is they will switch the breaker. They will upsize the breaker, and that is a mistake right there. you're not really fixing the issue by upsizing the breaker. When you start to upsize the breaker, um, upsizing the breaker is wrong. Um, only if you're upsizing it on let's say you have a 20 amp breaker, you want to upsize a 20 amp breaker, and you're going to put it on a 14 gauge wire. You're upsizing it is definitely something wrong. What is the significance of the amount of switches inside the breaker box? I noticed some are larger than some based on the building. Okay, what is the significance of the amount of switches inside of the breaker box? So you must be talking about the breakers. If you are talking about residential, um, you're going to, so residential have different, many panels have different size breakers. So I'm going to show you an example right here. Um, so these are the same type breakers. This is a 20 amp two pole. This is a 20 amp two pole. This is a Scrady breaker. This is a GE breaker. This is a lot bigger, as you can see. Um, I'll show you the example right here. As you can see, I'm going to turn on my other. Okay, you can, yeah. Okay, so this is a lot smaller than this. So it all depends on the manufacturer and the way that they design the panel. Again, also, you will see different size breakers because some panels, some panels have, when it comes to your your hot tub and so on, it has to be on a GFCI breaker on the outside. So you'll see those breakers are a lot different. They're a lot bigger. Commercial, what makes it different is because it's a three-phase system, and you actually have three lines in one breaker. So when I say three lines in one breaker, so this is two wires that's going to go in here on a commercial industry now. Um, Depending on what you're doing, you're going to have an extra breaker here on this side here, which is going to give you A, B, and C. So those breakers become a lot larger. So yes, it all depends on what you're doing, um, the environment you're working in. Um, it also depends on the panel that you have. Um, so again, uh, commercial industry, you're going to see the breakers are a lot different. I think that's what he was asking. Some are larger than some based on the building. So okay, so your question: some are large based on the building. Um, it's not necessarily on the building. It all depends on the panel. Like I said, on the panel. So again, a lot of commercial buildings, they carry heavy duty heavy duty panels, and in these heavy duty panels, they carry a lot bigger breakers. So that's the difference when it comes to the breakers. So I hope I answer your question there, Gloom Platoon. So again, for all those who are tuned in to the live stream tonight, don't forget to tap on the screen to like up the live. And again, for all those who are tuned in, you can for those who are tuned in, if you do have your comments, you can drop them in the comment section. Again, I'm going to give the live stream another 5 minutes here before I do log off the live stream. Okay, so again, let me. Yes, yes, Bloom Platoon. No problem. You're very welcome. It's my pleasure to share the knowledge. If someone has a question, yes, it's my pleasure to share the knowledge with you guys out here. Again, I'm just here because this is what I do, and this is what I like, and I do take the trade very, very likely. Again, there's many of us that don't, you know, return off the job site because of simple mistakes that happens. So it's always best to make sure that you are aware when it comes to electrical. You know, oversizing breakers and so on. It's just something that you need to pay attention to. Again, when it comes to electrical, it's just when it comes to electrical, it's just there. It doesn't. If there's a problem and you trouble it, it will occur. Um, yes, safety is Gun, Gun Platoon. For me, safety is high. It's always been high. Again, I'm the type of person, if I am working off of ladders and so on, I'm very aware of my surroundings. As you know, a quick nick on the ladder, you're out of your 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 you're out of work for a while. So injuries, um, I'm always aware of my surroundings when it comes to wiring and so on. Um, Again, I always want to make sure that everything is perfect and okay when it comes to electrical. And again, what helps it also is the inspection. Again, the inspector is there to to oversee your work and make sure that everything you did is up to code. So that's basically how I go about wiring. So again, for those who are tuned in to the live stream. Don't forget to like it up. This is live Q&A. You can drop a comment in the comment section. Again, for all those who missed the beginning of the live stream, don't forget to catch it on the replay. And again, on jobs, I actually use a breaker for this. Again, it saves time instead of flipping breakers. I've dropped the link at the top of the live stream. Click on that link, and then you can go from there. So again, that's what I use to troubleshoot. It's a new breaker finder that I have, and it's very great. The breaker finder, it does a lot of things that many people are not aware of. You can do so much with the breaker finder. Um, it's a great tool to have. So again, check it out. Pinned on the top of the comment section. Uh, so again, back to the live stream. I don't want to really veer off of the live stream. Again, for those who are tuned in to tonight's live stream, type yes if you've seen this mistake before. Let me know in the chat, residential or commercial. So I'm going to give the live stream another 5 more minutes before I actually log out of the live stream here. So again, for all those who are tuned in, don't forget to you can also subscribe to the channel. You can subscribe to the channel, or you can become a member of the channel, either or. Again, and again, you can follow me. You can follow the live stream. I go live on every Wednesdays. Every Wednesday, I do go live. So for all those who are curious, I do go live every Wednesday. Around 9 p.m. is my live stream. Again, this is a live Q&A. You can drop your comment in the comment section. Let me know what you think about the session. Let me know if you're a homeowner, or if you are a DIY electrician. Drop a comment in the comment section. It is a live Q&A, and you get to ask your questions. I get to answer them for you as best as I can when it comes to the knowledge and being in the trade for so long. So again, this is the rules that I've been using for tonight's live stream. For all those who missed the beginning of the live stream, you're going to see this rule along with 14-104 on the live stream. This is where I go to find the code rules. Again, a lot of mistakes that happens on the job. It's not because of us being be a lot of times we are aware. A lot of times journeymen are aware, electricians are aware, but a lot of times, sometimes it could be just tiredness, laziness, what, um, and that's the reason why sometimes you'll see uh, breakers mismatching and so on in the panel. It's not because um, we don't know, or the person before didn't know. It could be a simple, laziness happening, guessing instead of using the code book, which is very dangerous. Um, Always best to overcheck to and double check the rules. So again, for all those who are tuning in, don't forget to tap on the screen to tap on to like up the live. Again, this is live Q&A. For all those who are tuned in, you can drop your comment in the comment section. Again, for all those who are tuned in, type yes if you've seen mistakes before, such as oversizing, overcurrent, overloading the circuit, using the round breaker on the wire. Type yes if you've seen this before. So I'm going to do a recap here, just before a quick recap. If there's no one doing the Q&A, I'm just going to do a quick recap of what I went through here before I do log out of the live stream tonight. So again, summary, my quick summary of the live stream was basically breakers are designed to protect your conductors from overheating. If a breaker is oversized, the wire can overheat before the breaker trips. Understanding breaker sizing and continuous load calculation is critical for safe electrical installation. If you're an electrician or apprentice, this is something you need to understand to avoid overheating and fail inspection. So again, what breakers actually protect? Again, for all those who are tuned in, this is just a recap of the live stream. So what breakers actually protect? Breakers protect conductors and equipment. Number 14 gauge wire will slide on a 15 amp breaker. So for all those who missed it, number 14 gauge wire will take a 15 amp breaker. Okay, that's the normal code rule. If it is aluminum, you're going to have a number 12 on a 15 amp breaker. Okay, so again, number 12 wire on a 20 amp breaker. Again, breakers protect the wire, not the device. So under rules 14-104, rule 14-104, overcurrent device. Breaker must not exceed conductor ampacity. It prevents conductor overheating. So number 14 gauge wire on a 20 amp breaker. Again, that's a violation. It's basically a fail job. So we're gonna go on to rule 8-104. Again, this is a recap. Maximum circuit loading. Continuous load, again, must be calculated at 125%. Sometimes it's good to get a second opinion to see the difference when you're getting a house wire. If the opinions align, then you can go ahead with the electrician you choose. Your I mean, he says sometimes it's good to get a second opinion. Yeah, it's always good to have a second opinion, but again, um, it you never know what you're going to get. It's basically a lot of times it's also word of mouth. Also, that's great. And then a lot of times, you can look at the person's work if they're posting it online and so on. You the way that person posts and so on will tell you how they will do their work. But yes, a lot of times, it's always best to have a second opinion, and then you can um, correspond with the you can double check what the first person say to the second person to see if it aligns. Merits your work. Merits your work. Merits your work. Yes, definitely. Um, so again, you can get a second opinion. That's what a lot of people do. They will get a second opinion, but it also depends on the person that how they present themselves, and how they talk to the person that will determine if you're going to go with that person or not. A lot of times, like I said, if the person is you know genuine, and you know for instance, me, if I go and I go to quote a job, I'm very straightforward. I will tell you what you need to change and so on. I'm not going to hide anything. Um, stop me. So again, it's all about the appearance also, and how you present the work. A civilian won't see the mistakes that easy as a professional tradesman. Yeah, for sure. A person is not going to see the mistakes. For instance, I was doing a job about 2 weeks ago, and what happened was they removed the drywall, and there was one spot where it was taped. Everything was taped. Nothing was in a box. It was hidden behind the drywall. So for me, normally when I see something like that, I know there's going to be other issues in that same area. If the person made one mistake like that, they're going to make uh, a lot more mistakes like that. What that shows you is the person didn't know what they were doing. So again, yes, as a person in the field, um, and someone who's just a homeowner, or so on, or a DIY, or whatever it may be, or a apprentice who's not experienced and so on, um, they might take it for granted, and with the wire hidden, the one wire hidden behind the drywall and taped up, they might not. They might decide not to check the entire area where they are, which is a bad move, because if you have one mistake, you're bound to have a second and a third and a fourth mistake in that same area. So that's the difference between a professional person going about their work, and again, it all comes back to the knowledge also, and knowing what you're going to see. So again, this is Rule 8-104. This is the 80% rule that I went through. For all those who are tuned in, if you missed the beginning of the live stream, this is just a quick recap before I log out. This is live Q&A. You can drop your comments in the comment section for all those who are tuned in to the live stream. So, Rule 8-104, maximum circuit loading. Continuous load must be calculated at 125%. So this rule comes out of 8-104. Maximum circuit loading, continuous loads must be calculated at 125%. Again, this is continuous load. And when they say continuous load, they're talking about motors and so on. Something that runs continuously. You have to size it accordingly, 125%, because the motor is running constantly at 125. So it's running constantly, so it has to be calculated at 125%. Example, 20 amp breaker, 20 amp breaker times 80%. It gives you a 16 amp continuous load. Example, electric heater drawing 16 amps. A 20 amp breaker can safely carry about 16 amps continuously. So a 20 amp breaker can safely carry about 16 amps continuously. Very important, guys. The continuous load when it comes to heating and motors and so on is a whole lot different. So that's why a lot of times you will see your motors and so on are tripping. For instance, if I am going to be sizing a pump, even if it is a receptacle for the sump pump, I'm going to make sure that I go to 20 amps, because when it comes to motors, you have something called a inrush current. So what that inrush current does is it shoots in straight, fast. Your inrush current is faster. The startup is faster. So you will require a bigger size breaker to handle that inrush. What is a common danger with circuit overload? So a common sorry again, Gloom Platoon. So Gloom Platoon asks, what is a common danger with circuit overloads? So circuit overloads, what happens is when you overload the circuit, a common danger that's going to happen is it's either going to trip the circuit, or when the circuit is overloaded, it's going to burn the wire. It's going to burn. It's going to short circuit out. If you don't have no protection on the circuit, so let's say for instance you have what we call a arc fault breaker. So this is basically an arc fault breaker. Okay, this is designed to protect your wire from overheating. It's basically shuts the circuit down. So when your circuit is overloaded, this is supposed to kick in and shut the circuit down. But what happens is when the circuit is overloaded, this is not going to work accordingly. So again, when you overload the circuit, you're asking for problems. you will probably burn the receptacle out. That's why a lot of times also you will see that one receptacle will be burnt out and your other receptacles are not working. That one receptacle that burnt out is going to stop the flow of current from going through to the other devices. So when it comes to overloading, avoid overloading the circuit. The It's always best to the 20% rule that they have. That 20% rule is basically there to protect the wire. So when you overload the circuit, that 20% rule cannot take effect because the circuit is overloaded, and your receptacle is either going to burn out, it's going to trip, it's going to keep tripping. That's why a lot of times you'll see in the washrooms, if you have your bathroom receptacle and you're using your hair dryer and your bathroom receptacle is hooked up to the lights and so on, that's why you'll see a lot of times your circuit will start tripping because that circuit now has gone into overload. So that's basically what happens when you overload the circuit. So again, Rule 8-104, it says maximum circuit loading. Continuous loads must be calculated at 125%. Example, math, 20 amp breaker times 80% equals 16 amps continuous load. Example, electric heater drawing 16 amps. A 20 amp breaker can safely carry about 16 amps continuously. So again, real installation, you have your EV charger circuits, you have your electric heaters, you have your lighting loads. Again, these are all sized accordingly. It's always best to make sure that there's nothing else on the circuit when you are connecting your EV charger circuit and your electric heater. So again, on jobs, I've seen 14 gauge wire on a 20 amp. Again, that's a problem, and that's how overheating happens. So you have overheating, and you also have overload. So again, we're just going to be running through this quickly here. So oversized breakers, round conductor sides, ignoring continuous load, continuous loads. These are common mistakes that you see on the job site. So again, common mistakes I see on job sites: oversized breakers, round conductor size, ignoring continuous load. Again, always best to make sure. Small mistakes in breaker sizing can create serious overheating risk. So what breaker sizing mistake do electricians see most often? For me, most often I see is the 14 gauge wire on a 20 amp breaker. Again, you can type in the comment section if that's what you see on your job site. Have you ever seen a 14 number 14 wire on a 20 amp breaker? Um, do you apply the 80% rule on continuous load? So again, do you apply the 80% rule on continuous load, which is very important, or do you just go with the something called rule of thumb, the guessing game? Um, what do you do? Okay, so again, for those who are tuned in, I'd like to thank you guys all for tuning in to tonight's live stream. Um, I want to log off of the live stream here. I will give it 2 minutes, then I'm going to log off the live stream. Again, I would like to thank you guys all for tuning in to the live stream tonight. Also, like to thank uh, Goon Platoon and Frynet for stopping in to the live stream. So again, subscribe if you want real electrical work and code explained properly. And again, I would like to thank you all for tuning in to tonight's live stream. And I will see you guys on the next live stream. Yes, definitely, Gloom Platoon. Again, thank you guys for tuning in and stopping into the live stream and supporting the channel. And again, I will see you guys on the next live stream.